Hello world, it's Rational Pi and we're back here today with episode 2 of our Ascii art algorithm. And as you can see here, I created the Shadow of the Colossus logo in Ascii art. You can see the hash marks, the @ symbols. That usually represents the darker colors. The dots usually represents the lighter colors. And as you see, if you remember the original picture, all the words were in white and the background was in black. The only problem with Ascii art is because they're characters and there's a lot of spacing, sometimes the resolution can be off and you can't really tell the here in the middle, but you can clearly see Shadow and Colossus. So let's jump right back into the code, shall we? So back in our main method, we went over this last time, how to bring a file into C#. So now we're about here in the flowchart of things. So what is a bitmap? A bitmap, as we mentioned last time, is a map of bits. And that's how we determine the pixel location whenever it pulls in a picture from the external folder. So what we want to do now is we want to determine the size of the image. And each individual bit or pixel has a red, green, and blue specifier. That's how it determines what color it is. And that's what we're going to be using. We're going to be transforming that information on the color and we're going to be translating that into an ASCII symbol. And so I determined 310 for my width of my new picture just based upon the size of my screen, how many symbols I could create, and that I don't have to keep scrolling back and forth to be able to find my whole image. And then the ASCII height is going to be based upon the height or the width itself, and we're going to go over that in here just a second. So now we're going to go to this ASCII aspect ratio method, and we're going to input the image that we pulled in, the ASCII height, and the ASCII width. So let's scroll upwards. So ASCII aspect ratio, right here in the middle, this method right here. So we're going to pull in the image, we're going to pull in the height, the ASCII height, and ASCII width, and we're just going to replace it with H and W, just for convenience sake. So this method preserves the aspect ratio, not ration, I can't spell, based on the desired width of the ASCII art given. So H, height. And I want you to imagine this in algebra. I know algebra, right? If you're watching this, you're probably pretty good at algebra. So A over B is equal to C over D. Okay, what is that? A over B, or height over width, is what's called the aspect ratio of a picture. And we want the aspect ratio from before to equal the aspect ratio after. So when I say A over B, or height over width, that's the original height over the original width is going to equal to the new height over the new width. And so what we did here, because we picked the new height, we just need to solve for the width. Okay, so, and that's what we did here. So image.height, which means the original image height times ASCII width divided by the original image width. That's how we find the new height of the ASCII image. So now we want to create a new bitmap template based on the new width and height, and that's what we did here. The resulting bitmap is equal to the new bitmap with the height and width that we just found. So graphics is basically an ability that C# has to draw a picture or draw a piece of art or draw something. It's creating a graphic. I don't really know how best to describe that. So we're going to create a graphic from the image of the result. Okay, so the result is again that new bitmap we just created with the width and height that we just found. And so interpolation mode, what that eventually does, it finds the best method to find the difference between this pixel and this pixel. And that's what interpolation is. You're interpolating data from two given points. So it's trying to fill the gap using this interpolation mode. And so high quality bicubic is the most high quality method that the graphics component of C# can manage. And so we're going to create a new image using this interpolation mode. And what dispose does right here, it basically just takes all of the this resources that you're using to create this new graphic, and then it reallocates them back to the code. And then we're going to return the result. Now the result that we created is not the ASCII image. We're just taking the original image and resizing it. That way, whenever we create the ASCII image, it's not super big or it's not super tiny. We're basically resizing it to the proper aspect ratio that we're personally looking for, right? So now, and we're going to show that by going back to our main method. The original image is going to equal our new picture that we just created, right? So image equals the return of the ASCII aspect ratio method, and that's what we just did. So we're setting it up to where the aspect ratio of our new image is not going to be too big, too small, and it's going to be the exact size we want it to be. And that's one way we can control not only the quality, but also the size and resolution of our new picture. So let's go ahead and go back up top, make sure that we covered everything we want to today. Was Bitmap, how you can find the individual pixel information. Okay, so the individual pixel information is here. And we're going to go over this in the next video actually, but you could actually find out the color of the pixels by this color method here. Color pixel color is equal to image.getPixel at the width and the height that you're looking at. So you can set a red value, and it's from 0 to 255. That's what's going to determine the sharpness of each of the colors. So if you have a color that's 255, 255, 255, that's black, 0, 0, 0 is white. And basically it's the intensity of the color is this value that we're finding here. So we're going to find the red value, which is pixelcolor.r, the green value, which is pixelcolor.g, and then the blue color, which is pixelcolor.b. So it's RGB based. And then you're going to normalize it, dividing it by 3, because we're going to grayscale it, and that's how we're going to determine which ASCII character we're going to be using based on the intensity of the grayscale. And that's what we're going to cover in the next video. So I hope you're learning some things. At the next video, we're going to be talking about converting the image to ASCII, and we're going to be talking about how we're going to set it up and displaying it. So I believe that covers everything we wanted to cover in this episode. I hope you guys enjoy so far. If you have some pictures that you want me to Ascify, please comment below or shoot me a tweet at rationalpi_YT, and I'll be happy to do that for you. If you have any thumbnails you have for your videos that you think would be cool in ASCII, then I'll be more than happy to do so. It'll take me 5 minutes, and I can do that for you for no problem. So I hope you guys are enjoying. A like and subscribe is always appreciated, and I will see you all in the next video.